Okay, here we are. So here we're in our spring semester 2020, and we're teaching a class called Bio for Health-Related Sciences, which is Bio 1140, and you guys have a test on Friday. It'll be your first one of the semester. So if you have any questions, now's a good time to type them in, and we can get started with this review. And like I said, the review basically is dependent on the questions you ask me, and so as you keep asking me questions, we can keep having stuff get reviewed. And there's plenty of questions that I've posted online and UNM Learn for you guys to have. So I didn't get any emails at all. So let's see if anybody's got any questions. Well, while you guys are probably trying to queue up and figure out how to get some questions, I'll tell you really quickly a few things you need to know for this test. One of them is you got to remember the chemical bonding, covalent bonds, ionic bonds, and hydrogen bonds. You need to know that. You need to know basic atomic structure as well. And in class today, what I did is I gave you an example of how to start with understanding and foundational knowledge. So your foundational knowledge is memorizing the terms, protons, neutrons, and electrons, and that those make up atoms. And that, the protons and neutrons are found in the nucleus, and the electron is found in the electron shells. This is basically memorization, and that's where our knowledge begins. So you got to get all these vocabulary words down from these first 3 chapters. And then understanding is going, okay, why would a molecule of water, why would water be liquid at room temperature versus natural gas like methane or ethane be a gas? And the reason it has to do with the types of bonds that are forming that hold the molecules together and their ability to form hydrogen bonds. So you need to know polar and non-polar covalent bonds. And if you remember, polar covalent bonds, they're sharing the electrons unequally. And what that does is create a molecule that has a partial negative and a partial positive end, which allows it to form hydrogen bonds. And when you can form hydrogen bonds, you can stick together and you can be a liquid. Natural gas, on the other hand, like propane or ethane or methane, they're made up of non-polar covalent bonds. They're sharing those electrons equally. And as a result, they don't have any poles. They don't have a plus and a minus end, so they don't stick together very well. So they're a gas. And whether or not you have polar or non-polar covalent bonds is due to the electronegativity of the elements, which is a function of the protons in the nucleus and the distance to the electrons in the electron shells. So that's where understanding comes into play. And a lot of people come and tell me, Tom, I understand the material, but I'm not doing well on your quizzes. And my first response is, I hate to tell you, but you really don't understand the material. You most likely become familiar with a few words here and there, and that's about it. So make sure you know the difference between just becoming familiar with words, memorizing a few definitions, and actually understanding what those words mean, because this test relies on understanding, and without understanding of the material, you're not going to do very well. Okay, so I haven't gotten any questions yet. I'll double check email really quick, and let's see if we can get. No, I haven't gotten any emails yet. Well, guys, I don't have any set way to tell you how to study or any questions I can answer without anybody giving me some questions here. So no live chat. All right, guys, I got 7 of you online. More now. All right, I'm gonna give you a couple more minutes to log in and write a question. If not, I'm gonna end this review that nobody's asking me any questions on, and I'm gonna go home basically. And I will be around campus early tomorrow, and don't forget that your test will go on. Okay, we got our first question. Can you go over the laws of thermodynamics and entropy? That's a very good question. The laws of thermodynamics govern energy transformations. And this is very important because life requires energy. Life has to have a constant supply of energy coming in. And if you cut life off from energy, life dies. So there are 4 laws of thermodynamics. There are 2 that are most important for living systems. The first one is energy cannot be created or destroyed. That means that every system, like the universe, every closed system where nothing can get in and out, has the same amount of energy. It's got a set amount of energy. You can transfer and you can transform energy. Like if you throw a ball, The motion of your hand is being transferred to the ball. That's an energy transformation, or energy transfer, I mean. A transformation is I can take kinetic energy in sunlight, and a plant through photosynthesis can store that as a carbohydrate, which is basically sugar. So I'm transforming energy from kinetic energy to potential energy. Now, the second law of thermodynamics basically says every time you use energy, which means every time you transfer or transform energy, some of that energy gets degraded, which means it's becoming less useful to us. And as we degrade energy, we increase a property of the universe called entropy. Entropy is a measure of disorder. So in a closed system, once again, a closed system is nothing's getting in or out of it. Entropy is always increasing as the amount of available energy to do work also decreases. Now, the total energy is always staying the same, but that useful energy, the stuff that we can use to do work, constantly degrades as entropy increases. Now, that for life means we cannot recycle energy, because every time we're using energy, we're degrading its quality, and so we can't recycle. That's why there's no perpetual motion machines. That's why you need a constant supply of energy constantly coming in. So what life does, the relationship of life to the laws of thermodynamics and entropy, is life is constantly using a source of energy to create order and maintain homeostasis, some type of internal balance. And yeah, life outside of its boundaries as a system does generate lots and lots and lots of entropy. But at our levels, we are reducing entropy. So a living system is an island of low entropy. We are very ordered compared to our surroundings. So I hope that helps out. Okay. What are the odds we didn't evolve to have wheels? Not because it's illogical stuff, but because it's not any efficient evolutionary traits. Yeah, that'd be hard to evolve wheels. I mean, you could have some type of moving feature like that, right? I think in his Dark Materials, he invented an animal in that sci-fi series that kind of evolved wheels from a seed or something, and they had these long claws that they could stick into the seeds and use for wheels. That was pretty wild. Why are covalent and ionic bonds different? Well, first of all, a covalent bond is sharing valence electrons to complete the valence shell of electrons. So remember, electrons are found in these shells outside the nucleus. The first shell needs 2 electrons, and for carbon, nitrogen, and oxygen, their second shell needs up to 8 electrons, and most other shells need 8 electrons too. So these elements like carbon, nitrogen, and oxygen, and hydrogen, they share their electrons to complete their valence shell. Now, an ionic bond, this is how we form salts. You get something like sodium and chlorine. Well, the electronegativity between those two elements is a lot, right? So what happens is the chlorine atom basically just rips the electron pretty easily away from the sodium, and it forms ions. Because I'm taking away an electron from sodium, what's happening there is that it's becoming positively charged. As the chlorine atom picks up the electron, it becomes negatively charged, and an ionic bond is formed by the electrostatic attraction. It's just opposites attract, plus and minus ions attract each other, and you formed a salt. Okay, good question. So just to sum it up, covalent bonds share electrons, ionic bonds do not share electrons. Okay, how are hydrogen bonds formed? Okay, hydrogen bonds, for one, these are weak attractions. They do not form molecules or compounds, but they can hold molecules together, different molecules together, like water molecules can be held together by hydrogen bonds. And let me find a piece of paper here. I've already had that out. The way a hydrogen bond works, let me send that out here like this, is let's say I've got a molecule of water. There it is. Here's our molecule of water right here. So I've got an oxygen, and this line right here represents a covalent bond between the oxygen and the hydrogen. This is not a covalent bond. This is not a hydrogen bond. It is a covalent bond. Specifically is a polar covalent bond because the oxygen is pulling the electrons to it. So as a result, the electrons spend more time near the oxygen, and it becomes partially negatively charged, and this hydrogen here becomes partially positively charged. Okay, Remember, this is a covalent bond. This is not a hydrogen bond. A hydrogen bond is between molecules. And here we've got two molecules of water. Now, because we've got these polar bonds, and this molecule is polar, meaning it's a negative end and a plus end, this oxygen will be attracted to that hydrogen, and they stick together. And this is why water is liquid at room temperature, by forming this hydrogen bond, which is a weak attraction, specifically a weak electrostatic attraction between these polar molecules. Okay. Can you explain what happens when you add an acid to a buffered solution? Okay, we've got a couple things here. Let's look at an acid. Let's think about the acid inside of your stomach. It's called hydrochloric acid. Now, what happens when you put hydrochloric acid in water, it quickly comes apart and forms a hydrogen ion. Yes, I know hydronium for anybody that's into chemistry. But this ion here and this chloride ion here. So this comes apart into these two ions. This lowers the pH because I've increased the concentration of hydrogen ions. Remember, potential of hydrogen, pH, measures how many of these hydrogen ions I have. The more hydrogen ions I have, the lower the pH, the more acidic. Now, if you have a buffer, we have something called carbonic acid and bicarbonate. What a buffer like this does, a buffer like this molecule here, carbonic acid, can be put in water, and depending on the pH, can become carbonate plus a proton here. This is acting as an acid as it goes this way, because I'm increasing the concentration of ions. Now, if I'm adding an acid to this, I'm lowering the pH, and I force the reaction to go back this way, which means it takes up this hydrogen ion, and it lowers the concentration of the hydrogen ions and raises the pH. So the way the buffers work, they can act as an acid or a base. So if you're adding an acid to a buffer, it's going to act as a base, taking up those hydrogen ions. On the other side, like this, if I'm acting as a base, it will, if I'm becoming more and more alkaline like this, then the reaction will go this way, releasing this proton, and it will lower the pH. So buffers prevent wide swings in the pH. Okay. The major difference between a prokaryotic and a eukaryotic cell. Okay, well, one of the big ones is structural complexity. If I were to take two cells here, this would be a eukaryotic cell, and this would be a prokaryotic cell. Prokaryotic cells include bacteria and archaea, and they're very small, and structurally, they're very simple. And specifically, they lack what is called a cell nucleus, most organelles, and I'll write this down here, and specifically another organelle called a mitochondria. So the defining character of eukaryotic cells is their large size, but a nucleus that has all the nuclear material, and they have, most of them at least have mitochondria. And it's something we're going to talk more about in chapter 5 here. And prokaryotes are much smaller. They could be as much as 1,000 times smaller than a eukaryotic cell, and they lack the cell nucleus, they lack mitochondria, and they lack most other types of organelles. So they're structurally simple, but at the chemical level, based on their metabolism, they're actually pretty varied. Okay. Where are the vocabulary words to study on Learn? They're in the required reading. So in the required reading, at the end of each section, I have words that you need is the foundational knowledge that you would define. So as you're doing the required reading, like I said, it starts it off as the foundational knowledge on there. So make sure that you do the required reading and work through that. Okay. Any other questions here? Can you explain how to tell if isotopes are unstable? Well, they decay into daughter elements. I don't have a memorization of all the different unstable isotopes, but like carbon-14 has too many neutrons for its protons, and as a result of having too many neutrons, it'll decay into nitrogen-14 by basically a neutron converting to a proton, kicking out an electron. But the best way you can tell is if it's radioactive. Is it kicking out radiation or not? And the physicists have done a wonderful job of figuring all that out. Okay, any other questions? Are we good here? Okay, well, thanks for your questions, and good luck on the test on Friday. I'll see you then.